All right. All right, so let us start with your ion sheet, because since we're doing ionic compounds and they form ions, we're going to be using this side. Whenever we're doing these, there are no prefixes for naming ionic compounds. Okay, so you got to leave all that behind. All right, so there's a few sections, if you notice, up here at the top. All of these are single element ions. And what I mean by that, like it's lithium ion or magnesium ion, just one element, as opposed to the polyatomic ions. So if you look at the first three sections, those are all your positive. And all of them, but the most of them, that's supposed to be a positive sign, looks like an X. And then the next four are going to be the negative single ions. This little block, those are positive, and these are transition. Metals with one charge, and that'll make a little bit more sense as we move down to the next block. So they're transition metals and they only have one possible charge. And then in that little group 1 anion, that's hydride. That would be if hydrogen, instead of losing an electron, it would gain one. We probably don't really have to worry about that too much. I don't think it's one we use regularly. All right, in my next middle section, these are going to be transition metals with variable charges. So what I mean by that, if you look at copper, sometimes copper is A+1, sometimes copper is A+2. It depends on what it's combining with. And the Roman numeral behind it is going to tell you which charge is being used. So in other words, if I have copper, first of all, let's spell it. So if I have copper, Roman numeral 2, oxide, that Roman numeral is telling me that my charge on this copper is A+2. At this point, that copper lost 2 electrons because of what it was combining with. The Roman numeral always goes to the transition metal ahead of it, not ever to the negative ion behind it. We're going to be using the Roman numerals. All those other things are an old way of talking about what charge they were. All right, and then if we come down here, we have polyatomic ions. So this is a group of elements acting as an ion. So instead of just one element, we're going to have a group of them, and altogether they're going to form an ion. So if we look at carbonate, carbonate is CO3. So anytime I need to write carbonate, I need to write that whole thing. And then in this case, carbonate, that whole group has a -2 charge. Most of them are negative if you look at them. We have this one little positive one, ammonium, that's pretty common, but everything else is negative. There's a few of these over here that seem to get lost, and we use quite a bit, hydroxide and acetate. Also notice the endings on both of these. Up here on the single one, the ending has been changed to "ide," like we've talked about a couple of times. Down here, whenever I'm talking about my polyatomic ions, they do not have that "ide" ending, and we do not change it to "ide." We use it just like it is on the ion sheet. All right. Anybody have any questions about that so far? All right, so let's start our notes. Here. And I'm going to be putting some stuff out kind of to the side. I know sometimes that's hard for y'all to find a place for it. I don't know if you might want to get out an extra piece of notebook paper to jot some stuff down. Just give you the heads up on it. All right, so now we're looking at ionic compounds. So we have to leave the prefixes behind. And now instead of having a prefix to tell us what the subscript will be, you have to decide to right there, the subscript. You have to decide what the subscript is going to be. All right, remember a ionic compound is a metal and a nonmetal. Yesterday we did covalent, which was two nonmetals. So last unit when we were doing the Lewis dot structures, I said you need to identify what kind of compound it is before you start drawing it. But a lot of people still are not doing that step. So it was an ionic compound and they're drawing it like they're sharing electrons. Same thing here. If you don't look at your compound and decide what it is, you're going to name it or write the formula wrong. So as we've talked about before, when you're writing the formulas or making the name for an ionic compound, the cation, the positive metal ion, always comes first, and the anion or the second nonmetal ion is going to always come second. You have to determine the smallest whole number ratio of cations to anions, so you end up having an overall charge of 0. That means that it must be neutral. There is only one way for ionic compounds to go together. That's why we do not need prefixes. And if you do it correctly, then you should have a neutral compound when you put them together. That's not true for covalent compounds. I could have CO, carbon monoxide, CO2, carbon dioxide, but without ionics, they only are put together one way. All right, like I've already mentioned, you're going to need to use your ion list. You'll always be able to use that. And from that, you'll have to look what the charge is for the ions that you are dealing with. Some that you know that we've done a lot, you probably would know what its charge is just based off of the where they are on the periodic table. The charges are not part of the formula. So you kind of have to work with the charges, but then when you put them together to form the formula, they should not be hovering around somewhere. So like here I have NaCl. I shouldn't have like a +1, a -1. That makes that incorrect. That is not part of the formula. All right. So let's just work through a few of them. And remember, our big deal here is that we want it to be neutral overall. So the first one is sodium chloride. And sodium's a group 1 metal, so it has a +1 charge. And chloride is a halogen, so it has a -2 charge. So my plus and my minus, they're already equal to each other. So that means I just need 1 atom of each. It could be +1 -1. It could be +2 -2. If they're already equal to each other, you only need 1 atom of each. Some things about the subscript. or subscripts, never write a 1. Never negative. Because we're dealing with positive and negative numbers and kind of switching them around, but your subscript would never be negative. Must be reduced. So what I mean by that is, and this is not a true formula, but just so we can see, in a 204, something like that would be incorrect because I can reduce those subscripts. So what I would need to have is in A02. That would be the correct way if I needed to write that one. All right, so let's just work through some of these. We'll start with magnesium phosphide. Magnesium is a +2, phosphide is a -3. So what is the smallest number that both of those can go into? One can go into them, but these numbers have to go into it. 6, right? Smallest number both of those can go into is 6. So I'm going to put my mg. What times 2 would give me 6? 3. So its subscript is 3. I'm going to put my P for phosphide. And now it needs to be a -6. So what do I need here for my subscript? 2. 3 times +2 is a +6. 2 times -3 is a -6. You can also kind of think of them as changing places as far as the charges. So in other words, they kind of switch places. So this 3 would become the subscript for the magnesium. The 2 would become the subscript for the phosphide. That usually works, but you have to remember it has to be reduced. So like if I would have ended up with magnesium 2, P2, you would have to reduce that. All right, let's look at the next one. Calcium is a +2, oxide is a -2. So what would be my formula for that? CaO. They're already equal to each other. So nothing needs a subscript. Next one, copper. And notice it has that 2 in parentheses. Copper is more than one charge. So that right there tells me that it is a +2 in this compound. Like a little shortcut. Iodide is a halogen, so it's a -1. So if I think of them as switching places, the 1 would come to the copper, but we do not write a 1. The 2 would come to the iodide. So I would have I2 on that one. When I do that, I have a +2 on one side and a -2 on the other side. Then we have some polyatomic ions. There's several along here, so you're going to be pulling those from the bottom. Remember, they act together as a single ion. If a polyatomic ion needs a subscript, I'm going to put a subscript, you have to put it in parentheses and the subscript on the outside. Off the bottom, off of the polyatomic ions, they automatically put it in parentheses whether it needs a subscript or not, and that works also. All right, so let's look at a couple of those. So aluminum is a +3, and then I need to find my sulfate. Notice it doesn't end in "ide," so that kind of gives me a hint that it's going to be a polyatomic ion. So what's its charge? Sulfate, -2. All right, -2. It's at the end of this column. So I put my Al for aluminum. And what subscript is it going to be? 2. My 2 came over here, and then my 3 is going to come over the other side. I put my sulfate, which is SO4, just like it's written on here. I got to take the whole thing. And then this one is going to need a subscript. So what am I going to put on the outside? We let the 2 come over here. So yeah, the 3 is going to come over here. So I would have a 3 on that side. Thing I have is, for some reason, when people pull these polyatomic ions, they leave off like that subscript. So instead of writing SO4, they just write SO. So remember, you got to take it just like it's written on here. Let's look at one more here, and then y'all can try a few of them. So copper, little shortcuts telling me that it is +2. Acetate is a -1. So I'm going to write my formula. Cu for copper. Is it going to need a subscript?
No.
No. Acetate, if you find it over here in the first block, kind of long. C2H3O2. So I have to get all of that, put it in parentheses, because what's it going to need on the outside? A 2. That would be my formula on that one. All right, why don't y'all give those next 5 a try? Um, Cameron, did you say something or no? You couldn't see nitrate on his sheet. Right, iron bromide, what would we have? 2. Sodium sulfide. S. Lead nitride. B3N4. We remember this is telling me it's a +4 and nitride is a -3. You got to be careful because if you look, a lot of the words sound pretty close. If it ends in "ide," it should be up here. If it ends in "ate" or "ite," it's going to be on the bottom. Potassium chlorate. LO3. You can put that in parentheses. It doesn't need a subscript, so you don't have to. Either way works. And my last one on here. We're looking for nitrate. So if you look at the very bottom of your first, nitrate is NO3. And I need a 2 on the outside. This is telling me it's a +2 and nitrate is a -1. The same thing happened in my last period class. So it's just getting used to working with the ion sheet. All right, any questions on that so far? That's really the harder part of the two. If you're reversing it and you have the formula, it's usually pretty easy. So instead of using those names that I told you not to worry about, we use something called the UPAC or IUPAC system. And that's where the Roman numerals are going to be assigned to our transition metals and tell us what the charge is. And remember, it always is for the positive metal in front of the charge. And that's for any transition metal that can have variable charges. This sheet does not have every ion that is ever around in the whole universe. It has most of what we'll be working for, but I could give you any kind of transition metal, even if it's not on here, because if it's followed by a parentheses with the Roman numeral, it's telling you what the charge is. Like we've done before, cation is always first. Don't change anything on the name. Do not forget about our Roman numerals. Those become part of the name. If our anion is just a single ion, then we will change it to I. And once again, at the top, those are already done. If it's a polyatomic ion, all of those at the bottom, we do not change those endings. So if I look NaCl, Na is sodium, Cl is chloride. That's my name. Cameron, sit up, sir. I have to say sodium monochloride because there's only one way that they can go together. So here I have MgCl2, that is just simply magnesium. And then Cl is chloride. No prefix are needed. Na3P, Na is sodium. P is phosphide. Once again, I don't have to say anything about the prefix or how many I have. Now, if we look at our next one, Fen, iron is a transition metal. It's in the middle, so it can have more than one charge. So I have to figure out what charge it is. You kind of have to work backwards. N is my nitride, and it has a -3. So which iron am I going to have to use? And I only have one atom of it to cancel that out. I have to use my Fe3, my iron 3. I tried. That one nitride was a -3, so I need one iron that would cancel it out. On these, if you don't put the numbers, the Roman numerals, it makes them wrong. Next one, what would the name of that one be? Zinc. And then S is going to be sulfide. That's it. That's all I got to do. Now, if you have a polyatomic ion, like I said, you just get it right off your ion sheet. So if I name one element, so in this case, aluminum, and I have more than one element left, that's telling me those are come together as a polyatomic ion. So SO4 is sulfate. I just have to write aluminum sulfate, that's all. All right, why don't y'all give those 3 a try? We have for our first one is calcium nitride. Now the other 2 took a little bit more work. So my first one, PbCl2, what would that be? Lead. And which lead did I have to use? 2. And then chloride. And then my last one is also lead. But on this one, which one did I have to use? To use lead 4. An oxide is a -2, but since I have 2 of them, I have to have a total of -4. And I only have 1 atom to do that with. So that's why that one had to be the 4. All right, if you go to the next page, there's some practice. So why don't y'all practice on those for a few minutes? And I will come around and see if you have any specific questions. We're going to continue and give you a little bit more time to practice on this tomorrow. This is not what the quiz is over tomorrow. It's just over what we did yesterday. We will have a quiz on this on Friday.